morning, students. So yesterday we studied about the trapezoidal speed time curve. So today we are going to study about this quadrilateral speed time curve. So here you can see this is the graph of a quadrilateral speed time, and this is, as you can see, this is the curve with the point O, A, B, C, D, E. These are the points. Okay, and so yesterday we were watching that trapezoidal. So what was the difference between trapezoidal and quadrilateral? That this AB point in that was constant, so there was no retardation. Alright, so as you can see here, at point A the speed is v1, at the point B the speed is v2. Okay, and the time t1 is the accelerating time t2 is the free running time, and time t3 is the retardation time, and the total time taken by the train is total t, which is the sum of t1, t2 and t3. Alright, so here the same content, the same points has been taken in this quadrilateral speed time curve, that is alpha, that is acceleration, beta, the retardation. So here is a new term, beta c, that is retardation during this Kogi period. This is between A to B. This is known as beta c. Alright, so v1 is the maximum velocity, this one, as you can see, and v2 is a lower velocity, or you can say a different velocity. T is the total time of this period. So similarly as we have done yesterday, so what we are going to do right now, we will find the value of t1, t2 and t3. Alright, so as you can see that time is equals to what? Distance upon speed. Alright, so this, as you can see, all these points are mentioned over here, and you can find this value of t1, t2 and t3 as similarly as in the previous method. So what we are going to do, we are going to find the area of this whole curve under this O, A, B, C, O. Alright, so this can be divided into three parts, that is triangle OAD plus ABED plus BCE. Okay, so these two are the triangles and this is a rectangle. Okay, so as you can see, we just have to put these values, that is half v1 t1, as you can see from this, that is half v1 is this and t1 is this, that is height into this base. Similarly for this triangle, half into base, that is t3 plus into v2, as you can see here, that is v2 into t3. Okay, so here lies the difference, that how we will calculate the value of this ABED. So that would be v1 plus v2 upon 2 into t2. As you can see here, t2 is the total time, and v1 minus v2, this point v1 minus v2 by 2 into t2 will be the whole sum of this region. Okay, so what you can do here, we can calculate it into two parts, like we can calculate this area of this rectangle and we can calculate this area of this triangle. So when we sum up this, we will came to this conclusion. Okay, so similarly we are multiplying all these things and we are taking out the things. So what I have done, I have taken v1 common from this and v2 common from this, and I have replaced these value, like t1 plus t3 can be replaced by t minus t3, and t2 plus t3 can be replaced by t minus t1. Okay, so I have just cross multiplied it. I have multiplied v1 with t and t3 and v2 by t and minus t1. So here comes this differentiated value, and I got this value from this differentiated. As you know, these alpha and beta are these factors that I have mentioned above, and you know how to put those values right here, like we have discussed in the previous section. Okay, so here is the total area, the total distance which is covered under this curve, which will be half t v1 plus v2 minus k v1 v2. What is k here? As you can see, the constant which we have defined earlier, so that's the k constant. So here I have mentioned the k constant, that is half 1 upon alpha plus 1 upon beta, that is equals to alpha plus beta upon 2 alpha beta. Okay, so as I have told you that there is a new constant, that is beta c, that is retardation during coasting, and that would be v1 minus v2 upon t2. So this is the speed. So continuing with the value of beta c, we can conclude that v1 minus v2 upon t will be equal to beta c. So what I'm doing right now, I'm just taking all these factors into consideration. I'm multiplying t2 by beta, so I will get v2 minus v1 is equals to beta c minus t2. So I will put the value of t2, I will replace the value of t2 by t minus t1 minus t3, as you can conclude it from the time that the total sum time is equals to t1 plus t2 3 plus t3. So I'm just putting down the value of T2 over here in this segment, and I'm just multiplying all these factors. As you know that T1 and T3 can be replaced by V1 upon alpha and minus V2 upon alpha. So putting these values, you will got this value, a new thing. By putting the value of 1 upon alpha and 1 upon beta, you will be considering this new value of V2. In this value, you can see that V1, V1, V2, V1, V2, all these variable are present along with beta C, alpha and beta. So in this consideration, I have to find the value of V2. So here we come up with the final value of V2 in this equation. Through this equation, we do have all the variables like V1, V2, beta C, beta and alpha. As you can see over here, all the variables are present in this equation. So coming to the next topic, that is mechanism of train movement. So in this diagram, you can see over here there are two wheels. One is a motor wheel and the second one is a train wheel or the base wheel. Alright, so there are some points through which we can drive the derivation of mechanism of train. So this tells you about how the moment of inertia and force which would act on the wheel and drive the train in a particular direction. Alright, so this is the armature of the motor and this is the wheel of the train. Alright, so as you can see over here, this is the motor armature, this is the motor pinion. Inside this is denoted by the dotted line, and this, as you can see, the bigger circle is the wheel of this train, okay, with the diameter D2, and the diameter of the motor is D1, and total diameter is the capital D, that is showing over here is the diameter of the wheel once again. So the traction effort which is applied by the motor is F1, as you can see in this direction, and the traction motor of the total wheels is Ft, that is total force of traction which is applied on the track in this particular direction. Okay, so there are certain terms that we need to elaborate first. So the total T is the torque extended by the motor. F1, as I show you here, that is a traction effort on the pinion, that is from the motor end. Ft, that is traction effort on the wheel, as you can see over here, that is Ft present over here. There is a new factor, that is gamma. So what is gamma? That's in gear ratio. Gear ratio in this means that there are, you can see over here, there are two wheels, one is motor and another is wheel. So there are certain type of gear in which the ratio of revolution is manipulated according to the gear ratio, accordingly. So for example, if a small wheel takes 10 rounds to complete 5 rounds of a big wheel, that would be considered as 1:2 ratio, and it will be considered as the gear ratio of this wheel of this motor. So D1 and D2 are the diameters, as I told you. So what I am doing right now, I am considering the torque equation of these wheels first of all. So as you know, what is torque? Torque is equals to force into radius. So I don't know about the radius over here, so I'm taking the diameter into consideration to find out the torque value over here. So torque is equals to F1 into D1 by 2. So D1 by 2, what is basically called as a radius. So I'm taking out the value of, I'm finding the value of F1, which will be equivalent to 2T upon T1. So previously I've just found out the value of F1. Now what I'm doing, I am finding out the total force, that the total force of traction that is applied on the wheel, due to the wheel, that is Ft. So it would be equal to F1, that F1 we have considered, I have found it earlier, that was 2T upon D1, and N is the gear ratio, that's neta is the efficiency, and D2 upon T, that is the gear efficiency. So what I'm doing, I'm just differentiating all the things. I'm just collaborating the different these identities. So what I'll get finally, I'll handle this, and I'll divide D2 upon D1 and replace this D under this 2T term. So I'll get neta upon 2D into D2 upon D1. So I'll replace this term with a gear ratio, that is neta, and I'll get these I just missed this T term over here, so this T term will come over here. So finally what will I get? That is 2 gamma n T upon D. So this is the gear ratio, this is the efficiency, T is the total torque, and D is the diameter of the wheel, as you can see. So the total force of traction depends on the torque and diameter of the wheel. It is directly proportional to the torque and inversely proportional to the diameter of the wheel, as you can see here from this relation. So next we discuss about the adhesive weight. So what is adhesive weight? As adhesive weight is the ratio of the adhesive weight to the dead weight of the tree. Alright, so it covers almost 20 to 40% weight of this motor, or this you can say the whole train. So we are denoting that factor from this x, that is an unknown factor, so that we are getting a relationship over here, that is adhesive weight WA upon the dead weight total W. So dead weight, so WA, we are basically finding the WA, that is adhesive weight, that is the production of unknown weight into the dead weight of the train. So the dead weight is I told you it will be contained by 20 to 40% of the dead, so that is known as the adhesive weight. It's generally a multiplication of an unknown with the dead weight of the train. Alright, so next we will discuss about the coefficients of adhesive. So coefficient of adhesive is denoted by mu, and it is the ratio of traction effort to of the slip to the adhesive weight. So adhesive weight, as you know earlier, like it is denoted by WA, and the traction effort slip of the wheel is denoted by FT, as we have discussed just before. Alright, so FT, what FT was equal to? So FT was equals to 2 so FT was equals to 2 gamma efficiency into T upon D. Alright, so this thing, as I told you about, so this is FT. So as you can see over here, so FT, so we are just replacing FT with this I'm just cross multiplying it, I'm sorry. So FT will be equal to mu A into WA, as you can see over here, and I'm replacing the WA with the XW, that is this thing, W with the XW. I just replace this, and what I get this. So W, as you know from the 10th class, from the 10th standard, that W is equals to mass into gravity. So putting the value of gravity, that is 9.8, and mass in the newtons, so it would be around 1000 into 9.8 into x into mu into m. Alright, so it would be around 9800 mu x m. So this is the coefficient of adhesiveness. And these are the certain factor on which coefficient of adhesiveness depends, that is coefficient of friction between the wheel and the rail, series parallel connection of the motor, speed response of the drive, smoothness with which the torque can be controlled, and the nature of speed torque characteristics.